Welcome to the Stormsurf video surf forecast for the week starting Sunday, July 12th. Taking a look at significant wave heights for the South Pacific Ocean, we see not a whole lot going on in our standard forecast window. Small gale in the Tasman Sea is producing seas, but aimed in exactly the wrong direction, towards Antarctica. Another gale under Australia is not in any of our swell windows, and it is producing seas, but only 20 feet, and of no real interest. Another small gale, actually a storm, is producing 36-foot seas, but east of the Southern California swell window, right at about 118 is the cutoff there. If fetch were aimed up to the north, swell would be generated, but instead it's aimed at Chile and targeting only locations from Chile up into Peru. Let's get into the details. First up, let's take a look at jetstream level winds. These winds up about 30,000 feet help support the formation of storms, and when those storms do form, help direct their track. What we're looking for is a trough, that is a bow in the southern branch of the jet stream, that is this portion here, pushing to the north. That would help create a clockwise circulation in the upper atmosphere, as well as down at the surface. That is the signature of low pressure, and that helps create storms, and of course storms help create swell. Right now we have a split jet stream pattern, the northern branch of the jet, which really doesn't do a whole lot to support storm formation, tracking right on about 25 south, pretty much flat west to east. Down south, the northern branch is pushing, ridging hard to the south over the Ross Ice Shelf and nearly Antarctica, the whole way across the Pacific. Little tiny trough right here. We saw in the previous image some sort of activity, gale activity, is centered here, creating some seas. But again, that's all out of our forecast area swell window. So this ridging pattern typically sets up high pressure down at the ocean surface. Clockwise flow would be, a counterclockwise flow, that is the hallmark of high pressure in the southern hemisphere. Let's put this into motion, see what's going on. As we continue, we move into Monday, pretty much the same thing going on. This split pattern with a ridging situation going on. But notice here, another trough starts developing Tuesday off of southern Chile. Again, this has no bearing for the United States, but for South America, that would support a gale. And then another trough starts building. Again, still big ridging pattern going on here. This is 60 hours out. But yet another ridge. Here we go into Wednesday. We're looking for something, a break over here, some breakdown in this ridging pattern. We're not seeing it yet. And yet another much stronger trough starts developing Thursday here, and notice with the better part of 120 to 130 knot winds pushing up into it, that should help support at least gale, if not storm formation. And also notice the beginnings of a trough on Thursday under the Tasman Sea, but perhaps a break. And as we move into time, again, this trough here builds, but look at this. We're looking at 130 knot winds pushing almost due north on late Thursday. Let's see where that goes. Building to 140 knots into Friday. That's a good-sized trough, well north of, so the Antarctic ice is about at 65, let's say. We're almost at the peak of that period here, but anything north of there, up into here, this pocket is free and clear if a gale were to form there or a storm. And again, also this over here. Anyway, we're into Friday, and the pattern continues. The trough holds solid into Saturday. Big ridge develops here in the southeastern Pacific, and then the trough finally starts dying out come, late Saturday or so. But notice this, another trough that appears to be starting to build with not nearly as good a wind support initially, but here at 180 hours out, we're seeing some signs that maybe a secondary trough might start building. So this looks good for the area under New Zealand. Very consistent with what has been going on so far this entire summer season. That is, high pressure in this area, low pressure tracking under it, forming a gradient. Storms working their way either along the New Zealand coast or under New Zealand. The southwest swell window relative to California, Hawaii, and Tahiti has pretty much been the only source of activity, save this one little pocket of gales forecast for mainly Chile and Peru. Let's go see what all this means down at the ocean surface. So here we are. Surface level pressure, surface level winds. As expected, gale? No, a storm. Storm Anything more than 50-knot winds, we see 50, 55-knot winds aimed almost due north here at 90 west. Again, targeting this area only, not up into California, which is basically starting back here somewhere. So, swell for South America seems likely. Roll this out. Notice big high pressure here, as expected, between the split flow and the jet, and the main energy here, well south of, let's say, 62 south, pretty much over ice. Low pressure here develops in the Tasman Sea Monday night. Another gale, here we go, 40-knot winds, again outside of the California swell window. 45-knot winds into Tuesday, and yet another gale developing in a new trough there. Also a bit of a cutoff trough here forming south of Tahiti. The point being on this one, not so much swell production, though so maybe some little swell might result for Hawaii, but it would bring lower pressure over Tahiti, while at the same time higher pressure is starting to build over Australia. That would help send the Southern Oscillation Index negative, and when we get into the El Nino section of tonight's report, you'll see the meaning of that. Notice, though, that load develops pretty nicely. And anyway, back to business. 40-knot winds in the far at 120 west now, maybe some fetch in the California swell window, and here we go, 45-knot winds behind that, pushing rapidly to the east. And yet another gale. Here we go, 178 hours. That's Wednesday night. Again, for the most part over Antarctic ice, but trying to get some headway here. Let's just roll this out. And you can see, look at what we saw was that 60-knot winds forecast and free and clear of Antarctic ice, we believe. We'll know when we go to check the wave model, but a lot of fetch here, all aimed at Chile. Certainly swell for there. The cutoff low continues this Thursday south of Tahiti, and then we see some development starting south of the Tasman Sea. Roll this out. Another, wow, look at that. Still giant area, 50-knot winds, again, all aimed at Chile. But this is in the California swell window if it were to get some traction, but it's moving so fast to the east. Probably that is not the case. Roll this out. Now we see low pressure, a large low developing over New Zealand Friday night. This is a ways out. And look at this fetch. We got a lot of fetch aimed well to the north, targeting Tahiti and Hawaii would be the best guess at this point in time. Up to 55-knot winds, holding solid into 174, 180 hours out. This is a lot of fetch, but the core is even good and solid, aimed well to the north. If this were to happen, a significant swell would certainly result. Let's go take a look and see what the effect of these winds will have on the ocean surface if all plays out as forecast. So here we go, significant wave heights, South Pacific Ocean. And suffice to say, since the so there's swell that has been hitting California quite well. It's already passed Hawaii. Hit very well over the weekend, the late part of last week. That swell is fading out. Since the storm that created that swell, there has been virtually no activity in the southern hemisphere. So no other swell is in the water or expected to be in the water anytime soon. So we hope you got your fill of that swell. It was pretty good while it was here. Anyway, so let's start rolling out, see what's going on. We see low pressure, of course, in the Tasman Sea, but all the fetch is aimed south, and certainly the seas from it aimed south of no real interest. Roll this out. Here we go. Here's the next gale. 42 hours out on Tuesday, 30-foot seas. And just for fun, here is the Southern California swell window. We'll put this in here for the whole series of gales. Notice the arrows here are at perpendicular to the Great Circle paths. No swell radiating to the north, not in the swell window. Here's the next one. Also notice here's the cutoff gale relative to Southern California. Probably not a whole lot expected. But anyway, 30, 32, 34-foot seas on the 175-degree path. Maybe dribbles for Southern California at best. Now this one's a little more interesting. Here we go, 42-foot seas per this, the 18Z run of the model on the 187-degree path on Thursday the 16th to Southern California. And let's just see, that quickly races pretty much out. And the majority of the swell production happens over here, and again, perpendicular to the Great Circle paths. Nothing relative to California, or certainly not Hawaii. But then we are out 150 hours, and actually if we go back just a little bit, you see notice the trough that we were talking about that was building in this area, and we already see seas forecast to start being produced as of Friday. Maybe a little bit of 30-foot seas on the 222-degree path, very close to the cutoff from New Zealand. Probably not a whole lot of any interest. But when we get into Sunday, now we're talking a week out, we see a rather large area of 30-foot seas with embedded seas pushing near 36 feet, building into the 40, about the 46-foot range, right on the 214-degree path to Southern California. That looks to be shadowed relative to Southern California by Tahiti, and the 211 to 210-degree path to Northern California, and that too is just barely shadowed. And that was it. That's 180 hours out. So, but relative to Hawaii, certainly nothing to worry about there. Not aimed ideally at Hawaii, but not horribly bad either. In fact, the early part of this is pushing almost directly right up the Great Circle paths. So, again, though, it's 180 hours out. Hardly believable, but something to keep in mind. And then while we're at it, let's take a quick look at the North Pacific, not because there's any winter-like storm activity going on, but the tropics are definitely heating up with a series of systems. 1, 2, 3, 4, 5 systems on the chart. Now, this is just significant sea heights, which is rather a rough and crude way of looking at tropical systems, but it gives you the general idea. What's going on here, westerly winds, strong westerly winds, or westerly wind bursts are in effect in the equatorial Pacific. That helps create basically eddies north of it, and that is how you get tropical systems during the active phase of the MJO. Anyway, so this is Nangka. It's off of Japan and heading north. We'll see where that goes. These other systems are of no real interest, expected to fade out. Maybe something over here, Dolores, tropical depression Dolores to build. Anyway, so we roll this out. We're into Monday, and here's Dolores building Nangka, heading north, and we'll just watch this as it goes here. Nangka heads into Japan. Dolores is more of interest to California if it does what it's supposed to do. And you'll see it here moving up into the Southern California swell window. Now, it's not supposed to be a particularly strong system, but certainly some swell should result. And this system actually now is forecast to strengthen. What we're looking for is recurvature to the north and northeast heading towards the Gulf of Alaska. The interesting part is Nangka actually is supposed to go into the Sea of Japan, dissipate, but its remnants get sucked up into this low here. So we'll see what happens. If we were in a good El Nino situation, it's still very early in the year in July, but it would be interesting to start seeing some recurvature of these systems off to the northeast. That would give us a sense of how strong the jet stream is, whether it's capturing tropical activity, and that would be a hallmark of El Nino. And since we're having that discussion now, let's just take a quick look at the jet stream. So look at this. This is July. Early in July, we have a cohesive non-split jet stream defined in flow running across the North Pacific down at 45 north. This as of Sunday, July 12th. You typically wouldn't see something like this until the fall. Already it's in play, and it's not just some fluky little thing. We'll just roll this out real quick for the week. Notice this, a legitimate trough on Thursday is carved out with supposedly 140 knot winds pushing into it over a small area. But still, this gives you some sense. And then here we go again, even by the weekend. More development out this way gives you the sense that the jet stream is certainly much stronger than normal for this time of year and much better configured, and that leads us to believe that perhaps El Nino is getting some traction in the upper atmosphere and having an effect. It's still a little bit early to know. Again, what we want to see is tropical systems getting caught by this and redirected towards the Gulf of Alaska, and we do not see that yet. But since we're at it, let's start talking about El Nino, or at least the Southern Oscillation Index. Difference in pressure between Darwin, Australia, and Tahiti. The current daily number, minus 3.80, basically neutral. Notice we were at a very good long run of very negative numbers in the latter part of June, early July, attributable to a major active phase of the MJO, one of near historic proportions. The current result of that is The 30-day running average is down at 15.65, basically holding steady. And the 90-day average is down at -10. We want to see this move to about -15 and be stable and holding. Notice it's far from stable. If one were to think that El Nino is in play, that's where we need to be, about -15. Graphically, here's another way to look at the 30-day running average. Back in 2013, it was all in positive numbers, indicative of La Nina, and certainly the inactive phase of the MJO. In early 2014, there was a big dive. Things started looking like maybe El Nino was trying to get going, but then it rebounded up into positive territory. But then in July last year, we started getting a good run of negative 30-day averages, and that's only continued to deepen into July. If you want to draw a line through it, it'd be roughly about like that. We still had a big spike here in June, but now the active phase is well in control, probably bottomed out, didn't get quite as low totally as a pulse back in May, but still we're in pretty good shape. We just don't want to see this go too awfully high. So earlier we indicated we were in the active phase of the MJO. Major westerly wind burst is in effect, or has been in effect. As of July 6th, we'll just do a quick little recap here. Here's the West Pacific. You can see westerly anomalies. The reds indicate strength, pretty much going from beyond the maritime continent, or over the maritime continent, over the dateline, to a point basically almost south of California. And we just roll this out here and you see that is still the case. Notice a little bit of easterly anomalies starting to develop here. This is at 850 millibar level, up about 4,500 feet, but still westerly anomalies mostly over the Kelvin wave generation area, exactly as we would like to see it. And here's today's model showing westerly anomalies. Again, we're interested in only the area a couple of degrees, maybe if you stretch it 5 degrees north and south of the equator, from about 130 or 135, roughly. Draw a box right about here. If you have westerly anomalies in this area, that can help create a Kelvin wave if it has sufficient duration and strength. Clearly, we have moderate plus westerly anomalies in this area. This is a good thing. It's helping support Kelvin wave development. That's in the West Pacific. Coming across the dateline here, we see westerly anomalies continuing south of Hawaii, building to moderate strength or more south of California. This suggests that the core of the active phase of the MJO is moving east into the East Pacific at this point in time. Looking down at the surface, the TAO buoy array, these are actually hard sensors on the ocean surface. We see not a little bit of westerly winds, little pieces of fragments of actual westerly winds, but for the most part, it's represented by just a decrease in trades. Almost certainly no trades in this area, trades in the East Pacific. Here's anomalies, certainly westerly anomalies, just like we saw at the upper level charts, basically going the whole way across the Pacific. Nothing particularly showing any form of easterly winds going on. This is a very good sign, and it's a testament to the strength of the current active phase of the MJO and the westerly wind burst that it has created. And now here's where things get interesting. A week out, we see easterly anomalies forecast, this up at 4,500 feet in the atmosphere, in the Kelvin wave generation area. We do not want to see that. We want to see, if anything, neutral anomalies. This is the suspected inactive phase of the MJO starting to move over the West Pacific. If easterly anomalies move into this area, that would shut off warm water flow into or in the Kelvin wave generation area and perhaps have some stalling effect on the developing El Nino. Now, not to be alarmed here. The models typically have shown this. What actually happens down at the surface is normally not as bad as what's depicted in these charts. At least that's been the trend so far this year. So we're not too worried at this moment in time. And still notice westerly anomalies are supposed to be continuing here from about 170 east on across the dateline. That is the trailing final edge of the active phase of the MJ moving out. It's this inactive phase that we are intently interested in. And then, as expected, south of Hawaii, westerly anomalies continue as the active phase of the MJO lingers, but starts fading a week out over the East Pacific. So starting about the 20th of July is where things are going to get a little bit interesting regarding what's going on with the inactive phase of the MJO. A quick historical look back. The oranges and reds, we've seen this before. The purples are westerly anomalies. The area we're interested in is from about here to here, roughly in the Kelvin wave generation area. Starting about the 20th of June, we saw westerly anomalies developing, but it was about the 26th of June where very strong westerly, where the active phase really got a hold, started working with a El Nino base state in the West Pacific, creating very strong westerly anomalies. We assume that a major Kelvin wave is in the process of being generated from these not only westerly anomalies, but full-on westerly winds that took over the West Pacific, at least through the 6th of July. And the reality is, in the Kelvin wave generation area, even looking at the forecast here, we're seeing, here's the date line here. So westerly anomalies to continue through about the 14th of July. And if you look at this whole stretcher, that's 15 days of westerly anomalies with probably a 10-day core of just extreme westerly winds. We suspect another major Kelvin wave is in the process of forming right now below the international date line. So what's the forecast? Longer than a week out. Well, here we are, about a week out, and you see this is the outgoing long wave radiation models. Oranges and yellows indicate more sunlight reflectivity off the ocean surface, less clouds, presumably high pressure, presumably the inactive phase of the MJO. And here is the remnants of the active phase fading out in the West Pacific. So the forecast per the statistic model says the inactive phase is really not even supposed to get going pretty good till about 14 days out. The dynamic model is now picking up on the same pattern, though not as strong. It had been saying no inactive phase. That is not what's happening. It's suggesting inactive phase, which we could be presumed to mean easterly winds starting about 2 weeks out. So that would be basically the 26th of July or so. And that's about what we've been seeing from other data, suggesting the last week in July, the first week in August is the window where if there's going to be easterly anomalies in the Kelvin wave generation area, this is where it's going to be. The concern is if that develops, one would worry about there being so we've had 2 consecutive Kelvin waves, downwelling phases of the Kelvin wave cycle, no upwelling phase. If easterly anomalies were to develop with any strength, then potentially we could go into an upwelling phase of the Kelvin wave cycle, and that could kind of basically make a cooler pocket of warmer that would transverse the equatorial Pacific and so maybe put a damper on our El Nino. Now, the reality is we don't expect that to happen. We think the El Nino base state is strong enough that when the inactive phase moves over, all it will do is serve to dampen westerly anomalies. Maybe just end up with, sort of normal winds in this area for a week or two. And then the expectation is the active phase here will start working its way in and we'll be back to westerly anomalies. But nothing is guaranteed at this point. And here's yet one more way to view that. The green is the area of enhanced precipitation. This is at the 200 millibar level, jet stream level. Active phase moving out of the equatorial Pacific. Here is the inactive phase moving in, 22nd of July. So the deal here is, if this is your active phase, this is your inactive phase, your westerly winds are actually between the core of the two of them. And over here on this side, here's the next active phase and this the inactive, here's where your easterly anomalies would be. So you just sort of follow along, and this suggests that your easterly anomalies would be moving into the West Pacific, let's say the 25th of July, and maybe go out into here, maybe the 6th of August. And then as you work your way down, they're pretty much out of the Kelvin. So the Kelvin wave generation area ends at, just a shy east of the international date line. So by the 11th of August, maybe even the 8th, we'd be back into any potential for westerly anomalies. So we have this little window here that we're kind of concerned about, that we're watching. Again, we don't know whether it's going to happen or not. Just better to be vigilant and not be surprised. And yet one more view. So I think we've been through this a couple times, but anyway, this is how you view the active phase of the MJO. Where the dots are the date. So this is in June, and here we are in July, the 1st, the 2nd, the 3rd, the 4th, the peak of the active phase of the MJO, and this is looking sort of down on the circumference of the planet. Indian Ocean moving to the maritime continent, to the West Pacific, to basically the Atlantic area. The active phase peaked right on the very hairy edge of the chart, as strong as it could possibly be. The further from the strong center you are, the stronger the active phase is. There it is, as strong as it could be. Currently, it's just collapsing to nothing per both these ensemble versions of the model, and no immediate return forecast. And this goes out for 2 weeks. Next up, sea surface temperature anomalies. Differences from normal for this time of year. If we have El Nino in place, you want to see warmer than normal water in this region working its way out to here. The Nino 3.4 region is basically a couple degrees either side of the equator. Draw a box between 120 and here. If you have warm water there, then you're in El Nino if it exceeds a certain threshold. But that warm water gets here from first being here, being caught by trades and blown over into this area. And how does the warm water get here? It gets here by, believe it or not, westerly anomalies here on the dateline. We were talking about the Kelvin wave generation area. West winds blowing here, takes warm water that's normally in this area, pushes it to depth. It travels as a pocket of warm water the whole way 200 to 300 meters below the ocean surface, then hits Ecuador and the Galapagos, or gurgles up or erupts on the surface, and manifests itself in this sort of a triangle type pattern, and then starts getting caught by trades, making its way off to the west. Clearly, we have a bit of El Nino pattern in play for early in July. This is a rather strong pattern indeed. There aren't too many, in fact, none that we've seen like this, save the one from 1997. You also see cool anomalies off Africa. That is also part of the El Nino picture, and little pockets of cooler water working its way off the African coast. We also are now starting to see cooler water showing up in this region, but what you really want to see is it down here off of Australia. So just to take a look, here we go back to June 29th, just to get a sense. So sort of look here, see how the warm water pattern is developing and what you see. So here we are back 629, warm but not super warm, not as warm out here. And then you see more warm water building here and still solid here. And we'll just go back and forth. Old, new, old, new, old, new. The point being, we believe warm water is building in the Nino 3.4 region. Exactly what we want to see. Another way to look at that, you can look at it here, the anomaly pattern. 2.5 degree anomalies at 110 west. Building in coverage, you have to take our word for it. We've been tracking the exact line of where the 2 degree anomaly line is, and it's definitely working its way off to the west while not losing anything in this area. That's exactly what we want to see. And of course, the westerly wind anomalies that we talked about earlier. Here's another way to look at it. High res, 5K resolution. You can see warm water clearly building. This is a much more continuous buildup of 4 to 5 degrees anomaly, almost continuous the whole way from off the coast of Peru. We can zoom this in just a little bit more here so you can see it better. Before there was in distinct little patches, now it's covering the whole area. This is just as of about a past week and a half or so. And now pockets of 5+ degree anomalies, especially this one here is kind of interesting, showing up all around this area. Good sign, means a Kelvin wave is erupting in this area. This from the second westerly wind burst that occurred in early May, if I recall, right on time, or arriving 3 months later, early, May to June, July. Actually, it's not even supposed to peak until August, and already we have a good warm signature in play, and more warm water subsurface, and we'll get at that in a minute. Also notice here, this station's reporting anomalies of 4.6 degrees above normal. That's exactly what the chart depicts. Looking at that station data in more detail, and what we're looking at is down this column here. This is the anomalies, and this is the date. So April, we had 3 degree anomalies. working its way, little spikes of 4-degree anomalies in early May, kind of backed off. Then it kind of really started warming up in early June, up to 5.3 degree anomalies, backed off a little bit, but now it's just hovering right around 4.5 degrees. That's quite warm. That's like 8 degrees Fahrenheit above normal. Significant warming in that area. And then, of course, the subsurface view. This is satellite data from July 7th. Sea height differences, that is the actual difference in the height above normal. Positive anomalies like what we have here are indicative of warm water at depth. Warm water at depth displaces the ocean surface a little bit higher. 5-10 degree centimeter anomalies above normal, suggestive of a Kelvin wave at depth here. Looking at it another way, here's absolute water temperatures. You actually see the anchor lines on the TAA buoy array and the sensors on those anchor lines, but it is the anomalies that we're interested in. And the point being here is at least 5-degree anomalies here. There we go, do it this way. 120 west, that's south of California. Now the point being, there was another anchor line here. It's out. It went on the fritz. We suspect the water temperatures are actually higher than that at depth, down about 50 meters, going the whole way into the Galapagos. That is what you're seeing, this warm water starting to impact the Galapagos, boil up at the surface, getting caught by trades. The point being, again, that there is a large area of warm water here going the whole way out past California, 4 degrees above normal on the equator. That's 2 months worth of warm water, at least a month and a half. And if the eruption is only starting now, then we've got the better part of July, to August, early September before all this warm water drains out. Part 2. This area, 2 degrees anomaly. This was just a little sliver last week. Now it's significantly expanded its area of coverage. The reason being, westerly winds are pushing more warm water to depth, and with that, the velocity and duration of that westerly wind burst that's been going on since late June, we expect this area to get much bigger and much warmer. And basically what will happen is, as this one bleeds into the coast and erupts, this area is just going to start backfilling it. This is like the 97 El Nino. There was just this warm reservoir that just sat here and sat here. It could not dissipate because every time it got a chance to dissipate, there was another westerly wind burst, if not continual westerly anomalies. It just kept feeding warm water into this pocket. This is why we have some concern about the upcoming inactive phase of the MJO. If it shuts off westerly anomalies, it shuts off the supply of warm water to this area. Though still, we're probably very well set for months to come. But still, if you want to try to compare this to the 97 El Nino, you need continuous westerly anomalies without a shutdown. So that we're sort of splitting hairs here, but it would be nice to see westerly anomalies continue. And yet one more view. Here's the current pocket of warm water. We suspect this warm water actually goes the whole way to the edge of the picture here. Also, here's the developing new Kelvin wave, which will just end up merging with this one into one giant bubble of warm water. And then finally, the forecast for the Nino 3.4 region. Basically no change from previous weeks. Temperatures 1.5 degrees supposedly in the Nino 3.4 region as of this point in time, early July, building to 2 degrees by October, peaking out at maybe 2.05 or 2.1 degrees above normal for a short period of time, a month or so. That would put this in the strong El Nino category, but probably not super El Nino. And just to quickly confirm, sea surface temperatures in the Nino 3.4 region currently at 1.5, actually peaking up at about 1.6 a couple days ago, 1.462 to be precise, but a little bit of wobble. But basically, the model and what's actually happening appear to be right on track. So to wrap this up real quick, major westerly wind bursts still in play, supported by the active phase of the MJO, working its way across the eastern Pacific, supporting much tropical development in the northern hemisphere. And that is a good thing. And also, no real swell production occurring yet in the South Pacific, but come the later part of the week, a significant storm is projected under and east of New Zealand. And in the meantime, Chile to get the lion's share of the storm production isolated in the southeast Pacific. So, looks like El Nino continues its development. No immediate surf, but the odds are looking good for the future. Hope you got some swell while it was here in the California and Hawaii area over the past week. It looks like we're going to be in for a little bit of a downturn for a week or so, but that should be short-lived. So, thanks again. We'll do this. It's going to be not next week, but the week after. We're taking a little time off, so the next update will be later in July. Look at the Stormsurf tools. You can follow along yourself to keep up with what's going on. Otherwise, we'll get the updated forecast out as soon as we can when we return. Thank you.